Right. So, what is a monitor? At the lowest level, in simplest terms, the monitor is an ADT. So, if you have done the data structures course, which I believe all of you must have done or must be doing, the definition of an ADT is a mathematical model which contains some data element, basically some variables, as well as the functions that can be performed on those elements. So, an ADT basically is a capsule which contains some variables and a bunch of functions which can be performed upon that variable. So you cannot perform any function on said variable except those which are specified in the ADT. So that is an abstract data type, and a monitor here is going to be an ADT. So what does it mean? You have a variable. So a monitor is just a variant of the semaphore, okay? It's just an advanced version of the semaphore. So when I say the monitor has a variable, obviously we're talking about the semaphore variable. It's the same thing. In this case, you will probably call it the monitor variable, but it refers to the same thing. So you have a variable and you have functions which are the only functions that can be performed on that variable. So let's see what those functions are and what they do. So let's say here x and y are your variables. So your variables again are similar to the semaphore. They're going to what do they exactly represent? We will come to in a bit. It might not exactly be the number of resources as it was in the semaphore case, but in some sense this variable exists to give you an idea of whether a specific resource is available or whether you need to wait a bit in order to be able to access it. So that is the high level idea of this monitor variable. And as it is an ADT, along with variables you have also functions or methods, and in this case they are wait and signal. Sounds familiar from semaphores? So wait and signal are the only operations that can be invoked on these variables, but what exactly do they do is, the wait operation means that the process invoking this operation is suspended until another process invokes signal. So I will quickly run back to semaphores and we'll draw parallels with that and we will understand this. Right, so if you remember from semaphores, this was the definition of the wait and signal functions we saw. So the technicalities of it I have explained in the segment on semaphores. You can revisit it if you want to brush up. But ultimately, what are these functions doing? So the wait function is trying to claim a resource. It will first check if the resource has been completely taken up by others, in which case it will wait. And once it comes to know that at least one instance of said resource is available, it will claim that resource, right? And how does it come to know that said resource is now available? When some other process has finished with that resource and signals the release. That is what the signal function is about, right? It is giving up control of a resource and saying, I'm done with this, this is now available for anyone else among you to use. So that is what wait and signal were about. Now let's move back to monitors and look at this statement again. Wait means the process invoking this operation is suspended until another process invokes signal. Same thing, right? So wait means someone wants to use a particular resource, but that process is suspended until another process signals the release. So basically there's P1 which invokes wait, meaning it wants to claim a resource, say a printer. But when it invokes wait, it is suspended, as in it is made to wait until another process P2 invokes signal. So P2 is working with the printer. Once it is done, it signals the release of the printer. Until then, P1 has to wait. So once the signal function is called, exactly one suspended process gets resumed. So let's say P1 and P3 both call the wait function. And there's only one printer which is being used by P2. I repeat, you have one printer. P2 is currently using the printer. It has a claim over the printer. P1 and P3 both call the wait function because they both want to access the printer. Both of them are temporarily suspended. Now P2, which was using the printer, has finished whatever it wanted to do. It signals the release of the printer. It gives up the printer. meaning you have two suspended processes from which exactly one of them will be resumed. For example, let's say P1 is resumed. So now P1 acquires the printer, P1 works, then P1 will signal the release of the printer. Again P3 will be woken up, P3 acquires the printer, P3 uses it, P3 gives it up, so on and so forth. So if there is a resource which is currently being used by some process and some other process invokes the wait function, this invoking process will be temporarily suspended until said resource is released. How is it released? By the signal operation. So the signal operation will resume the suspended process. If no process is suspended, if the resource is available, no one is using it, then the signal operation has no effect, and when you call the wait function, you will directly get access to the object. So there are two things I want to mention here. So generally how wait and signal work is, I hope it is clear to you by now, when someone has control over the resource. But when no process is currently using the resource, when the resource is free, if you call wait, you will directly be given access to the resource, because the definition says invoking wait means the process is suspended until another process invokes signal. But nobody here is nobody has claimed the resource in the first place, so nobody is going to invoke signal. So if your resource is free, invoking wait will directly give you access to the resource. If your resource is held, you will have to wait, you will have to be suspended temporarily until someone else calls signals. That's it about wait. From signals point of view, if someone has taken up the resource and is using it and then they call the signal function, they are going to wake up exactly one suspended process. So like P2 is working on the printer, P1 and P3 are waiting for it. So when P2 is done, P2 will wake up exactly one of them and say, look, I'm done with the printer, you can use it. And then that person will take it, use it, and then it will pass it on to the next one. So that is one thing. Secondly, if nobody is waiting for the printer when P2 is working, P2 will just give up control and move out. So it is not going to wake anybody up if nobody is suspended. This is the most important point. If no process is suspended, the signal operation is not going to have any effect. This is important because this is one of the main problems we noticed with semaphore. If you remember, I said if you call the signal function first, okay, I'll go back to that slide. Right, here we are. So when I was discussing the problems with semaphores, I mentioned this thing where I said if you swap the order in which wait and signal are called, if you signal first and then you execute your critical function, then you go for wait, it becomes a problem because your semaphore value is being corrupted. I explained this in detail in one previous segment where I talked about the problems with the semaphore. So if this part is not clear, I would urge you to revisit that and come back. So that was the problem with semaphore, right? Your semaphore value itself is being corrupted if you signal first. But here when you come to monitor, if you signal, then no such problem is going to happen. Whether you signal before claiming or after claiming, if there is a waiting process, it will be woken up and it will be told, excuse me, there's a resource here, use it. If no one is waiting for it, then signal is not going to do anything at all, which means your semaphore is not, your variable is not going to be corrupted, or it's not going to point towards wrong data at any point. So that is that. So those are the wait and signal functions. I hope those are clear. But what about the variable? What about this variable itself? So ADT, I said, is variables plus functions, right? We spoke about the functions, but what about this X? Now the thing is, in semaphore, if you had a resource called printer and you had 5 different printers, 5 instances of the same resource, you initialized your S equals 5. Here what we do is, for each instance you have a separate monitor variable. So printer 1 has variable X, printer 2 has a separate monitor Y, and so on and so forth. So you don't increment or decrement X. The only things you do are wait for it or signal its release. So that is a monitor. So I know that was quite a handful of information. I'll try to quickly sum up. So the problems with semaphores I discussed in a previous section. I would urge you to visit that if you are not quite sure about it. So to solve those problems, we come up with something called a monitor. Now a monitor is an abstract data type, meaning it has a variable and a couple of functions which can be performed on that variable. So apart from these functions, you cannot perform any other function on that variable. You cannot increment, decrement, whatever. So this variable here refers to one instance of one resource. It does not refer to the category printers as a whole, but to one particular printer, which we will, for example, denote as X. Now the only things you can do with this variable are you can wait for it or signal its release. When I wait for it, if no one else is using it already, I will directly be given access to it. If someone else is using it currently, I will be temporarily suspended until that person is done, then I will be given access. That's it about wait. Coming to signal, when I signal, I'm saying I'm done with this printer, so you can take it up. So whether I was using it previously or not, all I'm saying is I'm done with this now. So I'm not incrementing, decrementing anything, so my data is not getting corrupted. So in that sense, it doesn't make a difference even if you use a signal before a wait in a monitor, right? So anyhow, coming back to signal, what I'm saying is, when I say signal, if there is someone in the queue waiting to use the resource, one of them will be woken up and the resource will be handed to them. If nobody is waiting, signal is not going to do anything, the process just exists. So that's it about monitors. This is a better alternative as compared to semaphores, because this problem of data semaphore variable getting corrupted, or if your signal and wait functions are interchanged, something goes wrong, those confusions are avoided.